Okay, today's chapter is 6, manufacturing process. When we say process in operations management, the definition is any part of an organization that takes inputs and transform them into outputs. Up to this point, this is operations. Take inputs, do something, transformation process, and then output. This is operations. All operations are process. But to be processed, process is all process is operations. But to be processed should be like this: greater value to the organization than the original input. So if use $100 input, and then output value is $100. Still, it is operations, but it is not a process because output value is not greater than input. So process is value added operation. So output value is greater than input, then it is process. Cycle time, the average time between completions of successive units, maybe like this. If produce first one in 10 minutes, second one 11 minutes, third one like 12 minutes, then average is 10 plus 11 plus 12 divided by 3 equals 11 minutes. So this is a cycle time to complete successive units, the average time, that is not cycle time. And the utilization in operations management, the ratio of the time. So utilization in operations management is about the time. So if I have 10 employees and then they work 8 hours per day, then 80 hours I can use. So this is kind of capacity. And then if they work like 40 hours, then 40 divided by 80.5. So this is utilization in operations management about the time. Okay, next. Types of processes: single stage process, multiple stage process. Single stage process, all of the activities are involved in a process using a single cycle time. In manufacturing system, such as an automobile company, engine shop, so produce engine. So if produce only engine, then it is single stage process. So all activities to produce engine or engine, then done all activities in single stage. So single stage process, multiple stage process, multiple groups of activities. That means multiple group of single stages that are linked together. So engine, produce engine, single stage, then this engine move to another stage in equipped in engine room, and then after that move to another stage and another stage. So to produce a car, many single stages linked together, and then there is no flow. So that is multiple stage process. In process, something problem buffering, a storage between stages, that is buffer, we call that buffer, where the output of a stage is placed prior to being used in a downstream. The buffer is a storage area so like stage 1 and then stage 2. So, and then part move to this way. Then between two stages, storage area. So this is buffer. If uneven capacity of those stages, then maybe there are problems. First one is blocking problem. When the activities in a stage must stop because there is no place to deposit the items just completely. Uneven capacity. If these stages capacity is like 100 per hour, this one can make 100 items, then if this one's capacity is 50 per hour, so every hour 50, 50, 50 pile up, and then finally, if there is no buffer or not enough size of buffer, then this one stops because of uneven capacity. So this is blocking problem. The next problem can be occurred, that is starving problem. When the activities in a stage must stop because there is no work. Or do it again. There are two stages, then buffer, and flow this way, uneven capacity. This case, this upper stage is capacity is 50, and then downstream 100. So if there are parts there, then this one send 50, this one use 100. So sometimes there is no inventory. So this one work continuously, but this one sometimes work, sometimes stop, sometimes work, sometimes stop like that. So this is starting problem. And next, bottleneck problem in process. the same problem because of uneven capacity. If there are 3 stages in process, then move this way. Then this one's capacity is 100, this one's 50, this one's 100. Then bottleneck occurs when the limited capacity of a process causes work to pile up or become unevenly distributed in the flow of a process. So this one looks like bottleneck. So this one is bottleneck problem in a process. So send 100, this one work 50. So if there is no enough buffer or no buffer, then this one stop because of a pile problem. And then here, stop because of uneven capacity, work 50, stop 50, and so on. So this point, the same problem as the buffering problem. The blocking problem here and here, starting problem. So if there is bottleneck in process, then blocking and starving problem can be occurred. Make to order system process and make to stock system or process. Make to order only activated in process response to an actual order. This time, we can buy Dell computer, maybe at Sam's Club and at Walmart. But before that, we could buy Dell computer online or by a phone call. At the time, when we order online or by phone call, then Dell computer starts making our order. So at the time, Dell computer used this make to order system, only activated in response to an actual order, our order. If we use make to order system, then both work in process and finished goods inventory kept to a minimum because they don't make final product. So there is no inventory. When a customer order, then start and send out to right away to a customer. So maybe no, maybe less inventory in this system. Make to stock system process activated to meet expected or forecast demand. So forecast future demand and then make, just make, and then inventory, stock in inventory, and then customer order, then send out like that. So custom orders are served from target stocking level. So if a company use this make to stock system or process, then there is some inventory, target stocking level of inventory. When we go McDonald's or Burger King, fast food restaurant, they use this hybrid process. Combine the features of both make to order and make to stock system or process. When you go McDonald's, then when you place order, then the McDonald's start making you order hamburger and so on. But they have already French fry and the bun, patty already there. So, and then when it's busy time, then they just make by forecasting during lunch time the demand of such hamburger type and so on. So just make, but not busy time when customer come and then place order and they start to make like that. So many companies try to use this hybrid process, combination of make to order and make to stock system. Measuring process performance. When we measure if process work good or not good, then we may use productivity. I think you remember productivity, that is output over input. So higher input process working good. And efficiency. Efficiency in chapter 1, efficiency means using possible low cost, then improve efficiency. So if there are two systems process, then same level of output, then first one use like $100 cost. The second one is like $200 cost. So efficiency of process, first one is better because you use less cost. So we can use this efficiency to measure process performance. And setup time means the time required to prepare a machine to make a particular item. If a company produces multiple product items, type A, type B, type A, type B, and so on, then use only one process, then type A come, then prepare this process for A, and then B come, and then change the process, and so on. So change or prepare process or machines for the particular item. So that is setup time. So if a process uses less shorter setup time, then a better process. Runtime, the time required to produce a batch of parts. Usually, production systems don't make one by one. Produce batch by batch, like 100 type A, 100 type B, and so on. So 100 type A, 100 type B. So if time to produce for one item of A, let's say 1 minute, then 200 minutes. If time to produce an item of B, then 2 minutes, and then 200 minutes like that. So this is 100 minutes, 100 minutes, and 200 minutes. So this 100 minutes or 200 minutes to produce a batch of parts, that is one runtime. And next one is operation time, that is setup time plus runtime. If it takes like 50 minutes to set up for type A, and then 30 minutes to set up for type B. So including this setup time and runtime, for type A to produce 100, runtime is like 50 plus 100, 150 minutes. For type B, 100 items, then 30 minutes plus 200 minutes equals 230 minutes. That is runtime. So runtime, anytime shorter, the better process. Throughput time. Throughput time is total time. The total time with the time spent waiting in a queue. So with that example again, type A, 100, then let's say setup time is 50, setup time, and then runtime is 100. Okay, then type B is to produce 100, then setup time is let's say 30 minutes, and then 200 minutes. So using one process line, then this one, type A come, needs 50 minutes of setup time and then runtime. But after setup, then this one produced right away. So total time is 150 minutes for type of 100 of type A. But whenever type B come, like right after starting type A, then this one should wait on 150 minutes until this one went through, then this one start. 30 minute setup and then 200 minute run. So plus 230 minutes. So this case, throughput time for type B is 380 minutes like this. So this one is throughput time for type B. Maybe type B first and then type A next. Then whenever it comes, then wait until previous type item go through. So throughput time is total time, including waiting time. So whatever time, shorter, the better. And then process throughput time reduction. How can we reduce the total time? Maybe if we can perform activities in parallel. Do you remember concurrent engineering? If we can do multiple jobs simultaneously, sequentially, or parallelly, like this, then we can reduce total time. Yes, so using a concurrent engineering. then we can reduce throughput time. And then if we can change the sequence of activities, if activity is A, B, this sequence, then this sequence needs 3 setup times. But if we change A, B, then only 1 setup time we need. So if we can change the sequence, then we may reduce time and then reduce interruptions. The interruption stop the process. Maybe many cause of interruption earlier, uneven capacity like 150, then stop, blocking problem, starving problem. So uneven capacity can be cause of interruption. That case, make it even capacity. And then another cause of interruption, breakdown, machine breakdown. So to prevent that machine breakdown, we need maintenance or preventive management. So try to reduce interruption, then we can reduce total time. And then types of process, project layout. The product remains in fixed location. So when we say project, it is a big one. So build a house, build a building, a ship, and so on. Product is there, and then machine or workers move around, place around, and then move around. So product is fixed. So we call that project layout as fixed layout. And the workstation type, similar equipment or functions are grouped together. If we go like an office or a retail store, clinic, then the layout looks like functional area or department type. So if we go a certain office, then here accounting office and finance office and marketing office and so on like this. If certain process come in, then that process is the same. Accounting, finance, marketing, and then manufacturing and purchasing department and let's say whatever purchasing and then whatever office. So first one process come in accounting and then manufacturing and purchasing and then out. Second one come in different paths and then out. Third one different like this. So if there are many types of works, jobs, but each type of work or job volume is low, small size, that case, using workstation type, layout, or process, And next one is manufacturing cell. Using group technology, make cell. So from this workstation type process, we can modify like this. If there are process department or the function area, let's say 1, 2, 3, 4, 5, 6, then type A need 1, 2, 5, type B need 1, 2, 6, type C need 3, 4, 5, and D need 3, 4, 6. Then find similar process. C and D, 3, 4, A and D, 1, 2, and then 5 and 6, similar process. Then grouped like this, 1, 2, 3, 4, and 5, 6 cell. Then type A come, and then send this way. Type B come, send this way. Type C this way and this way. So modify workstation type. If you use workstation type, then type A come 1, 2, 5 and out, 1, 2, 6 and out, C 3, 4, 5 out, D come and then 3, 4, 6 and out like this. So before using this cellular layout, using group technology, grouping similar process and then make cell. The path is very complicated, and then moving distance is longer than this one. This one is simple, and moving distance is shorter. So using this manufacturing cell or cellular layout type process, next one is assembly line. Less type of product, and then each product volume is large. That case, using this assembly line type. So many manufacturing companies use this assembly line. So it's line type, then workstation or stages on the line, and then go through this line. So assembly line type is straight line type. So many manufacturing company, when they produce not many types of product, and then each product volume is large, then using this assembly line type. The path for each part is a straight line. And continuous process, this one is similar to assembly line type, but the product is flow continuously, such as oil company or bottling company. The same one flow continuously. So this one is similar to the assembly line line type, but product flow continuously. Okay. That's all for today's lecture. I used 35 minutes. Anyway, today's lecture is short like this. And then next Monday, the same, in class, face-to-face, and Zoom online, asynchronous class. So if you want to come class physically, come to class, and then otherwise, see you online. Okay, any question? By the way, next class, go back to normal time, start at 4 next Monday. Okay, see you next Monday.
Have a good weekend.
Thank you too.
Take care.